Determine the gradient function dy dx for each of the following. And the first one is y equals 5x to the 4 minus 3x squared plus 7. So dy dx is, think about what we talked about in the intro. The 4 comes down and multiplies the 5. So that's 20. And then we reduce the power by 1, so it goes from 4 to 3. Going to do the same thing here. 2 comes and multiplies the 3, and the power goes from 2 to 1, and we don't normally write the 1. Now with the 7, that's 7x to the 0. 0 comes down and multiplies, and we get 0. So the constant term just disappears when we differentiate. The other way of thinking of that is that since dy dx is the gradient function, think about y equals 7. It's a horizontal line, so its gradient is going to be 0. Then for part B, we have y is the square root of x cubed plus 5 over x to the 4. The first thing to do is use our knowledge of indices. Square root is x to the half, so that term is going to be x to the 3 over 2. 5 over x to the 4 is 5x to the negative 4. And now we have both things in the form y equals ax to the n, and we know how to differentiate that. So we've got dy dx is 3 over 2 x to the power a half, just reduce the power by 1, and then here negative 4 is going to multiply the 5, giving us negative 20, and that would be x to the negative 5 because we have to reduce the power by 1. Since it was given in this form in the question, I'd probably write it back that way. So 3 over 2 root x, take away 20 over x to the power 5. Let's smarten that up. That 5 didn't look very good. There we go. That's a bit better.